Week 10, lesson 7. Okay, so this is talking about even and odd functions, okay? And I like to approach this with graphs first. So the three graphs you're seeing here in pink are considered to be even. And sort of the qualification is that they are symmetric with respect to the y-axis. Okay, so I think you know what that means. It means if I was able to actually physically pick these up and fold them, that one side would land right on top of the other. Okay, also, though, probably more important is this definition, that the original function, right, would be equal to the function if you put in negative x. Let me show you what I mean. So here, this ordered pair is 2, 4, and this one is negative 2, 4, right? Whether I put in x or I put in negative x, I still get 4. Okay, it happens over here too, right? This ordered pair right here is 3, 3. But this one over here is negative 3, 3. So again, notice it doesn't matter whether I put in positive x or negative x, the y values are equal. All right, and I can do it on this horizontal line as well. All right, so like this point right here is negative 4, 1. This point over here is positive 4, 1. Right? Doesn't matter whether I put in the positive or the negative 4, a positive 1 still comes out. Okay, so now these down below, these are called odd functions, and they have 180-degree rotational symmetry about the origin. Meaning, if you put, like, let's say a push pin right here or right here, and then you rotate it exactly 180 degrees, this would end up down there, and this would end up right there, and it would look exactly the same. Okay, likewise, here, if we put a push pin right in at the origin and we rotated this 180 degrees and this 180 degrees, it would still look like the exact same line. All right, and as far as the ordered pairs, right, this is 1, 1, this one is negative 1, negative 1. Okay, so notice, if you put in the opposite x value, you get the opposite y value, right? Here we put in 1 and we got out 1. But over here, when we put in negative 1, we also got the opposite there. Happens over here as well. All right, so let's say this ordered pair, this is 3, 3, and this down here is negative 3, negative 3. When you put in the opposite x value, right, consider this your original. If you put in the opposite x value, then the opposite y value also comes out. Okay, so on this page, you're going to see that I have a bunch of examples, all right, because they take a little bit of practice. So what you're going to do always is check for even first, all right? Functions are either even or odd, but never both, and you always have to check for even first. So to check for even, let me move that up, sorry about that. To check for even, you're going to do f of negative x, right? It's just evaluating the function with a negative in place. So if I put a negative in here and I simplify it, I end up with the original. That makes this even. All right? That means I don't even have to check for odd. I've already determined that it's even. Okay, so let's try this next one. If I put negative x into this function, I get negative 5x. So it's not even, right? This does not equal that, not even. So then your next step is to check for odd, which means doing this test. What is the opposite of the original function? The opposite of the original function is negative 5x. Now see how this equals this? That means it's odd. All right, so you check for even first. If even doesn't work, then you check for odd. Okay, let me move this up. Let's continue. Okay, so let's check for even. So I'm going to put a negative x where x used to be, simplifying that. I don't get even, right? Then I do the opposite. Let me change colors, actually. Sometimes different colors definitely help. Let's check the opposite of the original. Opposite of the original function is negative x cubed minus 1. And this doesn't equal that, so this one's neither. Okay, again, you're gonna have to really, really watch the negatives, watch the signs. Okay, let's keep going. All right, so let's check. Oh, that is the wrong kind of pen. Sorry about that. Here we go. F of negative x. So I put a negative x in there, a negative x in there. Sorry, that should be minus 3. Okay, so simplifying, I get x squared minus 2x minus 3. Okay, that is not the same as the original, so it's not even. Now let's take the opposite of the original. Okay, so if it's okay with you, I'm just going to take the original and make it opposite. Negative x squared, negative 2x, positive 3. That doesn't equal that. That one's neither. Excuse me. Okay, let's move this up. Got a couple more examples here. All right, so is this even? Let's see. Negative x to the 6th minus 2 times negative x squared plus 3. Let's see, negative 6 times itself 6 times is x to the 6th. This is minus 2x squared plus 3. Oh, hey, look, this equals this. This one's even. Okay, let's try this one. Let's see, f of negative x. So negative x to the 5th minus 5 times negative x. All right, if you take a negative times itself 5 times, it's still negative. This becomes positive. Okay, so it's not even. So now let's check for odd. The opposite of the original is negative x to the 5th plus 5x. Ooh, that equals that. Okay, perfect. This is odd. All right, let's check this one for even or odd. F of negative x is 3 minus 2 times negative x squared. That's 3. Let's see, this becomes positive, so minus 2x squared. Oh, look at that, even. Okay, so now we're going to check and see if this thing is even, odd, or neither by doing graphing and algebraic. Okay, so this is a piecewise function, right? Piecewise function. Between negative 3 and 0, it's a line. So let's see if I can get that graphed on there fairly accurately. Negative 3. Actually, that should be an open circle because 0 is not included. It has a positive slope. So 1, 2, 3. Pretty sure that's what the first part looks like. And then this, in a different color, this goes from 0 to 3. It has an intercept of 6. 1, 2, 3, 4, 5, 6. And a slope of negative 1. So it goes to here. Oh, but the 3, sorry, open circle. Okay, so there's the original. Okay, this is not symmetric to the y-axis, right? I can't fold it. And it doesn't rotate around, right? I can't go like this and get the exact same picture. So my conjecture is that this thing is neither even or odd. So this is what I'm going to have to do. I'm going to have to test it. So let's do f of negative x. So I get negative x minus 3, and then negative x plus 6. So negative x minus 3 and x minus 6, which is not the original, so not even. Next, let's do the opposite of the original. So this would make this negative x plus 3, and the bottom one, x minus 6, which is, the bottom one is, but check it out, the top one is not. Okay, so again, they both have to work. Okay, let's move this up. Okay, so another piecewise function. All right, the top one I'm going to do in blue. It's a parabola, but it only goes from negative 2 to 0. All right, so let's see. It's been moved left 2. There's the vertex. And then over 1, up 1, over 2, up 1, 2, 3, 4. 0 is not included, so that's an open circle. Okay, so there's the top one graphed in blue. Bottom one, also a parabola. It opens down. It's been moved to the right 2. This is an open circle. By the way, the open and closed circles are not really going to play that much into your even odd. This is a downward facing parabola, so there's a point here. Oh, no, I'm lying. Right here. Let me erase that one. And then 1, 2, 1, 2, 3, 4. This is open. And it looks like that. Okay. So based on my picture, I could rotate this thing, okay? I'm guessing this thing is odd, okay? That's based on the picture. Now, let's actually do the algebraic test. So if I put negative x into this function, I'm going to have negative x plus 2 squared. And down here, negative x minus 2 squared. Okay, let's actually multiply this out. If I FOIL this out, I get x squared minus 4x plus 4. And this one, I'm going to FOIL and distribute the negative. Okay, so I get negative x squared, negative 4x plus 4x, hold on, positive, negative 4x, positive, negative 4. Okay, so it's not even, okay, because this original and this original do not look like this original. And the reason I FOILed these out is so that I can check for odd. So if I do the opposite of the original, that's opposite of x plus 2 squared. And then the opposite of the bottom one is just x minus 2 squared. Okay, so let's FOIL this out. This becomes negative x squared minus 4x minus 4. And this one, when I FOIL it, is x squared minus 4x plus 4. This equals this, that equals that. That's why it is odd.